Good morning. In a time of great change in the world, in the United States, in the world, it's said that the transformation that is going on in electrification, in electricity, in transportation, and in our electric grid is bigger and more profound than any. And today we're going to try to take that apart. I want to open up right away. When, Chris, I'm going to start with you. When we're talking about a transformation of the grid, that the grid of the 21st century, which is the mantra that we hear, is going to be much different from now, what are we talking about? What is the problem, and what kind of a solution are we looking for?
Sure. Let me tell you where we've come from in a very short period. Technology is morphing and changing and becoming available faster than it ever has in our industry. Up to a couple of years ago, we didn't know if your power was on unless you called us. Monitoring on a distribution system was very limited. It was based off of previous engineering calculations on line size, load, what the demand would be at peaks, and so it was not a very intelligent system. In the last couple of years, out of our 10 million utility customers, we've put over 7.5 million smart meters on. Now we're starting to see how the system operates, the demands of the system, what our customers are looking for. There's a lot more intelligence that we can put on fault detection, fault isolation, but the customers now are becoming much more engaged in what they want to, how they want to control their energy consumption and how they want to manage the costs. So as the technology becomes available, the customer gets more control. How do we integrate that in maintaining the premise that it has to be reliable, it has to be clean, but it has to be affordable? So as we look towards the future, significant amount of distributed generation. How do you control the grid with that? There's a potential desire that one neighbor will want to sell its solar power to the other neighbor. And how do you manage that? So energy storage systems, energy management systems, intelligent operating systems, and trading businesses are going to be a big part of the future as we go forward.
And we need more electricity, right? 27% more electricity forecast by 2040.
That's the estimate.
Right. Peter, do you want to unpack that too?
Yeah. So firstly, it's very interesting to see this transformation from the outside. I thought I might warm people up actually by putting up a slide, if we can just have the slide coming up. If you go back a century, we had a discussion earlier about, gee, is the disappearance of productivity growth due to the fact that all of the big things were already invented and it's all been done? So actually beginning with this, what you're looking at is telecommunications and the electric grid in 1915. And if you look at those two pictures, aside from the fact that one is clearly in New York and the other is in California, and it's snow in New York and they have horses, and California, it looks like they just had a vehicle accident. But you may not be able to tell which of that was electric power and which of that was telephony. Right? If you look forward and click again on the slide, you see where that's gone. Okay? So those two things in 1915 were in many ways very similar. What you're just doing is you're pushing electrons out in one direction, in one case producing power and in the other case sending information. But by the time we've got to 2015, at least for telecommunications, everything has changed. There aren't any wires. The information is going around through photons rather than electrons a lot of the time. And there's been an amazing change of that. Whereas what actually happened on the electric grid, it's got bigger, and there have been many changes within that, but actually fundamentally, as Chris just said, the mechanism of what we're trying to do, has been until recently the same. So, a bit of my own history. I used to work for the phone company. That was when it was Marbell, AT&T. And when I started working for Bell Labs in 1980, the model for telephony was the same as it was in 1915. It was universal service at the lowest possible price. And the assumption was that you had a regulated monopoly which actually had, to deliver just that, and it was to deliver by cost, by price. Whereas, and everything changed after that. So one of the effects of that is that my phone bill is now, I don't know, about an order of magnitude higher than it would have been under the old model. And the reason I'm happy to do that is I get more stuff. And the question is that going the same way with energy? And I think it is. And Chris has already pointed out that you begin by having more smarts on the grid. You know what's going on. We're no longer in this central push out where you're regulated by price. There's real value. If you ask how much are people prepared to pay for energy, I do. Well, maybe it's 6 cents a kilowatt hour. But the best price I heard was if you go to a rock concert, it's been going for a few days, everybody's phone has run down, and then there's a business model of people will go out there and charge your phone for $10. You're not paying 6 cents a kilowatt hour to do that. So there's a very different model which may emerge with that.
All right. So Chris, just playing directly off of that,
right.
You've established what the problem is in the system and how in some ways it sounds primitive when Peter describes it. You have, as a bridge to getting there, you formed a relationship with MIT, Northwestern, and with Argonne, deciding that you didn't have internally whatever means of intellectually bridging that gap. Can you describe that? What are you lacking, and what is this relationship all about?
Sure. As a publicly traded company that provides energy delivery services and energy, there's not a lot of capability or balance sheet space for R&D, and so it is the jewel of our competitiveness going forward is the work that's being done at the national labs and the work that's being done at the universities, and how we can support the labs and the universities is a much more efficient model than us being a utility company or a competitive generating company trying to come up with our own Bell Labs type design. The work that we're trying to do, the partnership that we're trying to do is we know the practical on how the system operates. We have some insight into what customers want and what customers at this point are willing to pay. So we have a practical knowledge where the deep theoretical knowledge is within the labs and the universities, and how we can help commercialize that in a very affordable way, but a more expeditious way is what we're looking for with partnerships with the labs and the universities.
Yeah.
Okay, but Peter, the labs are research facilities. Chris seems to be describing a think tank operation, right? How formulating what the future looks like.
Well, I mean, that's what we're trying to do. So, we have to see how this works. So it's certainly not a model whereby Chris says, I have this problem, I need a widget, will you please design it for me and go back? We do work like that. Many of the labs do, universities do. We're really trying to get into a piece of white space and say, what actually are the problems? How can you think them through in a very different way? And of course, we can do that from a theoretical perspective, but it wouldn't be very useful if we didn't have a partner in Exelon to be able to do that, because we don't understand the constraints, we don't understand how stuff works, we certainly don't understand the market. And indeed, we are a research lab, so it's not appropriate, of course, for us to be doing certain classes of things, but it really is, I think, appropriate for us as part of a national endeavor to bring out competitiveness in the system, to be working with very forward-thinking companies like Exelon that want to think through this. But it's more of a think tank than it is, let's design some better widgets.
All right. So
Yeah.
let's have a mini think tank
Right.
right here. Now, if of course you only just started, and so what the future looks like is vague, to say the least. But you must have already had some brainstorming. Can both of you give some possible scenarios of what the world looks like in 2040?
Well, that's a risky proposition. The one thing we know is to stay on path is we have to stay educated. We have to stay informed. And relationships like we have with the labs and the universities help inform us as we're trying to define what is the utility of the future. It's another overused phrase, but as I said earlier, the customer desire, the technology advancements, the capability of our grid getting smarter, the data that we're going to get off of the grid, how to figure out the best way to use that. We do have a big picture vision that there's going to be much more distributed generation on the system. So you'll have more solar panels on individual houses, and how we operate the system and what the customers want to do with that is something that we have to be forward thinking about. We have to ensure that it's an equitable process that we go through. We don't see distributed generation serving the industrial load, and so if we compensate an individual at a house with a solar panel at the cost of the grid to the industrial customer, the commercial customer, or the metropolitan area, it would be difficult. So we have to keep a balance on what we think the future can look like, what the technology evolution is, and how we're able to keep that affordable energy component going so we can continue to drive competitiveness.
Yeah, well, it's never a good idea to try and predict the future, but there's a few odd things that may be out there. There are relatively conservative projections of energy use, but let me offer a non-conservative one, which is to note that while we're getting more efficient at using energy, for IT is now running at about 6% of global energy consumption. Now, if Moore's law were to continue, and I think this is one of the arguments that explains that it won't continue, running with current technology at 10 to the minus 14 joules per bit, you project that exponential growth, which is continuing to go on, and by 2040, the whole of the world's energy consumption will be for IT. That probably won't happen, right? But it means that, for example, and I think this was referred to in an earlier point, when we think about high-performance computing and the direction that's going to go and the way computing will permeate everything, there's going to be a model for computing which will change. And one possibility is that there will be much more computing on the edge of things. So rather than the current model we have where the data is kind of centralized, you take it here, you put it in the cloud somewhere. As I'm pointing out, the cloud is not, the cloud really is somewhere. It's in northern Finland melting the permafrost, probably. We won't be able to have that model of just beaming stuff around the planet. We will have much more intelligent agents which are out there doing computing on the periphery. So what does that mean for us, and how does that connect with the kind of stuff that's happening in this space? It begins with something which is relatively prosaic. In Chicago, we're just putting out about 500 sensors called the Array of Things. And these are things which sit out in the environment. They have cameras on them. They measure all kinds of things, gases and whether it's raining and whether there's a dog crossing the street and things like this. But it has a lot of smarts at the very end of this so that it compute with that, make decisions, and then call up City Hall and say, well, there's a flood in the street and you need to go and pump out the drains. That requires actually a lot of power. All of this is sitting on light poles, and it's being put up by ComEd engineers. So you begin to see how the need to put in power is not just going to be associated with people or with factories. It's actually going to be associated with autonomous stuff, which is all over the place. And that's one piece of the scenario that we're going through, along with the other things that Chris is thinking about, which is how do you integrate renewables onto the grid? How do you balance having wind and solar? And what other technologies do you need in order to get that to happen, including electrical storage, about which you know a bit?
So just throwing in exactly where you've left off, let's talk a little bit about politics. So in January, we have a very different administration coming in the United States with a very different idea about energy, about the environment. And I'm wondering, until now, for the last 8 years, the themes have been sustainability and green and renewable. Your decisions are 30 and 40 years in the making. To what degree, what we're going to possibly have over the next 4 and possibly 8 years, does that change what you're going to do?
The last over decade has been a frustrating period for our industry. We have environmental policies that are set at a desire to have a reduction in greenhouse gases and have a low carbon future. But that's an environmental policy, and it incents or targets specific technologies. It doesn't incent or design an outcome. The low carbon future is the dream of the current the current policies. The energy policy over on the other side does not incorporate the desire or the outcome of the environmental policy. So the way the markets are designed, it's around reliability and it's around affordability. It's not around low carbon. So we've had an issue with predictability on making investments. If you were to go out and build a new nuclear plant today, it would cost you $16 billion. It would have a 60-year life. The dilution period during construction is about 7 years. It's a huge investment. It's not something, even with our large balance sheet, we could do. And there isn't an energy policy that says go do that. So what we're looking for with whatever administration comes in is a recognition, if you're trying to get to a low carbon future, it can't just be on the back of renewables. You have to come up with some market design that says energy, transportation, agriculture, all of the industries together have a carbon footprint, and what is the most economical way to get to that low carbon future? If the new administration changes their mind or changes the policies and the positions at the federal level and leave it to the state level, we'll work it with the states. But our customers in majority of the states that we operate in have a desire for a low carbon future. The confusion over federal policy and the confusion that the state policy has got to be what we work out.
Okay, just trying to bring some clarity to what you've said. Are you now the shale gas has been a big driver in the reduction of CO2, and this has happened irrespective of anyone's policy, and it's resulted in utilities taking coal-fired plants off and putting gas-fired plants on. So that's a piece of the landscape. Are you speaking of nuclear then, of policies that encourage nuclear? And the other thing I wanted to ask is on low carbon, are you saying that irrespective of whether the new administration has a goal of an objective of low carbon, that's going to go on anyway because the states favor it?
A couple bites there. The current economics of the electric prices of electricity are really set by the marginal producer, which is the natural gas plant. Shale gas, the revolution that has come on to our industry has greatly reduced the prices of energy. It has made it more competitive. In many plants that were, say, the Eisenhower era, inefficient or less efficient heat rates, thermal transfer and heat rates, can't compete with these low natural gas prices. So there are some environmental rules that took coal plants off, and there's just the economics that have taken coal plants off. So that's been good for carbon reduction. A gas plant is 60% of the emissions of a coal plant. It has been good for economic growth in industry. So you know, there's a positive portion of that. And any plant that is in a competitive market needs to compete against the marginal producer. And if you can't compete against that marginal producer, then you need to be shut down, or you need to make the prudent business decision. There's a lot said in that. Just having everything on one fuel source is probably not the smartest way to go. So you have to design markets and evolve markets that have fuel diversity. This is not environmental policy yet. This is just sound, resilient to make sure you have a reliable system. A couple of years ago, the polar vortex came in, very cold. Our gas plants, our natural gas plants, couldn't get gas till 10 or 11 in the morning because the primary priority for natural gas is home heating. If you let the pressures go too low and you allow the pilot lights to go out in the city of New York, it could take a year to get in and relight those things. So there's some dynamics around the way the current system works that, yes, natural gas is good, yes, natural gas is competitive, but you need fuel diversification for reliability. So that's one thing. On the other side, if you're looking at environmental, we don't know where this administration is going to come down. We've heard some commentary, and then we've heard some retraction or just stated that they'll be looking at it. The Supreme Court has mandated that the EPA is to regulate carbon. Now, how that manifests itself, we don't know, but there is a court mandate to do it. We can invest in our systems, we can work within the business models as long as we know there's predictability. Like you said, our investments in our utilities or our investments in our power generation stack are 30 to 60-year investments. And in understanding you're going to be able to get a return on that investment is very critical. Over the next 5 years, we'll invest $25 billion into our 6 utilities. That's a significant investment. Half of it is debt on the books and half of it's shareholder equity that you have to be able to pay the debt and you have to be able to give a return on the equity. With the level of uncertainty that we have, that's a hard investment. The one thing I'll tell you, if we're looking at a low carbon future, we have to balance the technologies and the capability of the technologies. We think the future, there's a very bright future for energy storage and energy management systems, and that was the cornerstone of our new partnership with the national labs. That's got to be advanced, and we have to help commercialize that technology. But to do that and to maintain a low carbon environment, you have got to have an all-of-the-above strategy. When California shut down 2 nuclear plants, with all the investment that's been made in renewables in California, the carbon output went up 35%. Germany has invested significant amounts of money into renewable energy and technology and transportation capability. They determined they were going to shut their nuclear fleet down, and now they're burning lignite. If you look at the reduction of carbon in the country of Germany, it started down, it ticked back up, and now it's flat. There is some of the highest energy costs in the European Union based off of that design. What we're saying is, let's give us an outcome. Where do you want to go? And then let the market design how to get there in the most economic way, or give us predictability. If that's not what the nation's policy is about, then we know how to make investments and how to support these long lead investments going forward.
Yeah. Okay. I'm sorry.
Yeah, let me jump in there. So first thing I should point out from the perspective of the labs, we work for the federal government, and therefore the federal government suggests, sets the agenda, and we deliver on that. But you should understand that the balance between sustainability and manufacturing has actually tilted over the past few years. I would argue that what's actually happening in parts of the market now, particularly around electrical storage with electric vehicles, is that that's fast moving into a situation where people choose this because they want one. Right? And because they want one of those, then the technology needs to be there. So it isn't just, I think, driven by regulation or by a view of the market. Another point to come back in sort of a historical public-private partnership goes all of the way back to the founding of Argonne. So in 1946, Argonne was founded to produce nuclear power, right? To create all of the first generation of nuclear reactors, several of which you're now operating. And there was a very clear set of a public agenda which involved the transition of this new technologies into private industry for the benefit of the country. And so when you do have that purposeful policy which sticks for a while, then in fact turns out we can work together very well. We didn't, of course, put in nuclear power there because we thought it was low carbon. Wasn't the reason.
Too cheap to meter.
Too cheap to meter, apparently.
We have 1 minute left. I wanted to pose the other big thing that's going on: cyber attacks, cyber war. The German intelligence, British intelligence, and U.S. all are describing cyber attacks as a threat to democracy, to our systems. To what degree is protection against these attacks one of the aspects of this research?
So, partnership between the industry, the national labs, the Department of Homeland Security, and the DOE is very collaborative right now. It's very structured. There's an Electric Sector Security Council that we meet on a regular basis. We have live monitoring on 75% of the consumers, electric consumers today. We have monitoring on the systems of intrusion detection devices. It was with a partnership with the national labs we've been able to develop that technology. The labs developed it, and we've been able to commercialize it coming out. There's a significant focus on what we can do and what we have to do going forward, but it is really one of the best public-private partnerships that we have.
Yeah.
Peter?
Yeah, I mean, I think I agree, and no, that's a very important link. It's doable. I mean, at the moment, there's all kinds of stuff which is connected to the grid and the internet that doesn't have any security on it at all. So that's really vulnerable. There's a real opportunity, I think, as you go to more distributed systems to build in a level of resilience which is very different from being completely fail-safe. But undoubtedly, there are threats out there. There are people who are going to take advantage of our vulnerability. And again, that's traditionally one of the big roles for the labs to do. Remember that, we are here for the nation's security. That's our job. And that's something that we take very seriously. And there's a great partnership with the electric power industry on that.
All right. We're going to have to stop right there. Thanks very much, both of you.
Thank you.
Thank you. Appreciate it.